Okay, guys, last time we stopped at motion in one dimension, and we said that if we have an object that moves along one dimension, along a line, and if we draw the motion of that object, the position of the object as a function of time, we'll get something similar to this, anything. For example, we'll get that curve. So at time t1, the object was at position x1. At time t2, the object was at position x2. If we need to calculate the average velocity for that object, simply we connect between point 1 and point 2. We connect between point 1 and point 2 by a straight line. Then we find the slope of that straight line. That's the average velocity. And simply the slope of that line, it's x2 minus x1, which is that distance, divided by t2 minus t1. So that should give us the average velocity. And if we need to calculate the instantaneous velocity of that time, all what we have to do is to make, excuse me? Yeah, true. Or in other words, if we can make the difference between T2 and T1 very, very small, if we take T1 somewhere in here, so the difference between T1 and T2 almost zero, and we connect between those 2 points by a straight line, that will give us the tangent to the curve. Then we can find the slope of that line, and that will give us the instantaneous velocity. Simply, the slope, the tangent of the line, or the tangent line to the curve at that point, which is almost T2 on top of T1, should give us the velocity. In that way, instead of writing it, we used to write average velocity, V. So I'm going to use the black marker. V average should equal to change in position divided by the change in time, which is translated to x2 minus x1 divided by t2 minus t1. This should give us the average velocity. But if we take the limit which one? Are you sure? Okay, I'll get back to that. Okay. But if we take T2 minus T1 to be almost zero, that's what I wrote here, the limit when delta T goes to zero, then we write it in a different way. We write it that way. We write that whole thing to be dx over dt. And this is a mathematical process. What I wrote here, that's a mathematical process. It measures the change in position, guys, the change in position with respect to time. And we read it dx by dt. And this is the mathematical process. I will tell you how to do it. We call that differentiation. We find the derivative of x with respect to time. If you don't know how to do it, I'll teach you how to do it. But now there is a difference between average velocity and instantaneous velocity. And if you notice, for the instantaneous velocity, we just write v. So when we say v, velocity, then we mean the instantaneous velocity. But if we're talking about average velocity, then we have to specify that we're talking about the average velocity by writing v average. Okay, now I'll go back to the previous slide to explain what's the difference between x2 minus x1 over t2 minus t1 and what's written in the slide. And on the slide, it's written x at time t2. That's the bracket. What does the bracket mean? So if I write it, the position, that's how I read it. The position at time t2. Or I write it that way, which is equivalent to position at time t2. Same thing. Okay? Okay? Now, let's go back to dx by dt. Oh, this is the, oh. If you remember, we had the position as a function of time. This curve. And we had t1 in here, that's t1. This is point 1, and that's point 2. If we take those 2 points, if we take the difference between them to be 0, which means that point 1 is on top of point 2, that will give us delta t almost equal to 0. And this whole thing, that's a definition for derivative. So the derivative of anything, you find the difference of one factor with respect to other, when that delta t is very, very, very small, almost 0. And this is give us that thing, that formula, that mathematical process, which we call it derivative, which is the change in x with respect to time. How can we do this? I'll let you know. So now we know that average velocity is given by delta x over delta t, while instantaneous velocity given by dx by dt. Delta x over delta t, that's easy. Let's assume that x equal to, as a function of time, equal to t squared plus 1. Okay? This is a function that gives us the position. Can you see? Should I use a different color? Black. Can you see? Okay. Now, this is a function that gives us the position of the object as a function of time. Okay, guys? Let's do a simple table in here. X, t. At time equal to 0, what's x? What is the position of the object? 1. How did you know that? Simple. Time equal to 0. 0 squared plus 1, that's 1. Now at time equal to 1, what is the position? 2. So at time equal to 0, if this is the 0 point, the 0 displacement, the position of the object is at x equal to 1. After 1 second, the object has moved 1 more meter, so the object is at position equal to 2 meters. After 2 seconds, then it's at 5 meters. So after 2 seconds, the object is at 5 meters from the wall, from the 0 point. Okay, guys? So now we know what is this function mean? What does this function mean? Now we need to find the velocity of the object, the average velocity. V average equal to. If I tell you find E average, you have to tell me, the average between which 2 points. So I'm going to find the average between point t equal to 1 and t equal to 3. We need to find V average between time equal to 1 and time equal to 3. At time equal to 3, what's x? 10. 3 squared plus 1. So V average will equal to delta x, the change in x at time equal to 3, minus x at time equal to 1 divided by t3 minus t1, which is going to equal to x at time equal to 3, 10, minus x at time equal to 1, 2, divided by 3 minus 1. That's 4 meter per second. X is measured in meter and time is measured in second. Now we know that the average velocity between time equal to 3 seconds and time equal to 1 second is 4 meters per second.
So basically you're trying to find the average between
Any 2 points.
between 1 and 3.
Yes, in that case. And I can ask you now to find the average velocity between time equal to 2 and 5. Yeah, but that means that I do not, that means that I do not start from the origin. If this is my 0, if this is the 0, at time 0, when you walk to the room, you find me in here. Okay? It's the position. It's not the displacement. This is the displacement. Correct? Okay? So at my position, that's why I said this is the position as a function of time. So now we know how to find V average. Now we know how to find V average. And if I ask you guys now, try to find out the average velocity between time equal to 5 seconds and time equal to 2 seconds. Please do it. Find the average velocity between, find V average between time equal to 5 and time equal to 2 seconds. According to the same thing, same function, yes. 5 and 2 seconds. And please do not say the answer out loud. Just keep it to yourself for now. And if you don't know how to do it, just tell me, raise your hand, I will show you how to do it. Can you try? Yeah? Are you done? Do you have an answer? Yeah? Not yet? Okay. At time equal to, who did get an answer? What was the answer? 7 meters per second. Do you all agree? Okay. Let's find it together. Okay. How did we get that 7? They said V average will equal to X at time equal to 5 minus X at time equal to 2 divided by time equal to 5 minus time equal to 2. That's what they did. Okay, now can you tell me what will be the position of the object at time equal to 5 seconds? What's your name? Yeah. Hamad what? Nagy? Nagy. So can you tell me what is the position of the object at time equal to 5 seconds? You have the function right there. X equal to t squared plus 1. So at time equal to 5 seconds, what's X? 26. Minus. Nagy, again. At time equal to 2 seconds. Divided by 5 minus 2. That's 21 over 7. Oh, good. 3. That's 7 meters per second. Okay? That's how they got that 7. So now we know how to calculate the average velocity. That's easy. That's boring. Now we need something more challenging. We need to find the instantaneous velocity at x equal to 5 seconds. Sorry, 5 seconds. 5 seconds. We need to find the instantaneous velocity, not the average velocity. We need to find the instantaneous velocity at time equal to 5 seconds. I'll do the first one. Then now we have to do that function. That derivative. Do you want to ask something or do you want to answer? No. Now we need to know how to do that differentiation or that derivative. Rule of thumb, the derivative of any function, let's assume, excuse me, oh yeah, that's delta x over delta t when delta t goes to 0. That's dx over dt. How to do that derivative? Yes, I'll show you how to do it. But regardless of the derivative of the function for now, if you have x equal to t to the power n, find dx by dt. Dx by dt, that's a mathematical formula. It has its own way to find that. Simply, what we do is to decrease that power by 1 and multiply by the old power. So that's how we find dx by dt. It's going to be dx by dt equal to n times t to the power n minus 1. Now let's assume that n equal to t cubed, x equal to t cubed, so n equal to 3. So now let's find dx by dt. It's 3 t to the power 2. That's easy. This is how we do the derivative. What does the derivative mean? It measures the change of x as a function of time or with respect to time. How does x change when time changes? That's the meaning of dx by dt. Now let's go back to our function, and we needed to find, we had x equal to t to the power of 2 plus 1. So dx by dt, it's equal to 2t. It's 2, the power, n, and we decrease that power by 1. So it's 2t to the power of 2 minus 1, which is t to the power 1. That's correct. How about that one? So people who know, they said the derivative of that one is going to equal to 0. And people who don't know, let's assume that there is t to the power 0 in here. T to the power, anything to the power 0 is 1. Now let's apply that whole thing again. Let's find the derivative of that whole thing again. As long as you have a constant here, it stays as it is, 1. T, the derivative of t to the power 0, it's 0 times t to the power of negative 1, which is 0 minus 1. 0 times anything is okay, guys? So now we know how to do the derivative. Now we need to find dx, if you remember, by dt at time equal to 5. This, I asked you guys to find the velocity at time equal to 5 seconds. The velocity at time equal to 5 seconds, the instantaneous velocity at time equal to 5 seconds. We know that v is equal to dx by dt, which is this, that should equal to 2t at time equal to 5 seconds. Now replace t by 5. 10 meter per second. Now we know that v is equal to 10 meter per second. The v, the velocity at time equal to 5 seconds, equals to 10 meter per second. Do you get that part? Guys, do you understand that part? Nagy, you get that part? Can I give you another example to do it? Let's assume on a piece of paper, x equal to 2t cubed plus t plus 7. Find v average at time between time equal to 2 seconds and 1 second, and the instantaneous velocity at time equal to 3 seconds. I want that on a small piece of paper with your name and your ID on it. And consider that a quiz. And 1 second. The average velocity between time equal to 2 seconds and 1 second, and the instantaneous velocity at time equal to 3 seconds. Equal to t cubed plus t plus 7. Oh, time 2 t to the power 3 plus t 2 seconds and 1 second, between 2 seconds and 1 second. Instantaneous velocity at 3 seconds. So this is part A, this is part B. And if you want to cheat from your colleague, you can cheat from me. Ask me. I'll help you out. Yeah. I'll teach you how to do it. If you want to copy it from your colleague, I'll teach you how to do it. This is more beneficial. First, we need to find the average velocity, right? So you need to do this. You need to find x at time equal to 2 seconds. Okay. Then this is part 1. Then part 2, find position at time equal to 1 second. At time equal to 2 seconds, put time equal to 2 seconds. 2 times 2 to the power of 3 plus 2 plus 7. Blah, blah, blah. Get that number. Yeah. Then, do the same thing again. 2 times 1 to the power 3 plus 1 plus 7. Get that number. Then subtract them, divided by 1.
2 minus 1.
Okay? Do that. Tell me the answer. I'll teach you how to do the instantaneous velocity. Perfect. Perfect. But this is there's no x now. This is x. Okay, divided. And this is x. 2 minus 1. And 2 minus 1. Correct. Yes.
This is right. It's a calculation.
Oh, but you used a different formula. Oh, you're correct. Plus 1, correct. 3 seconds, 9, 54. Correct, that's correct. No, there's no such a thing. 54. Oh, I'll give you the mobile of my son, 15 years old, and he knows how to answer that. What's 6 times 9? Hey guys, that's good. Good. No. There's 2 parts for that problem. We need to find the average velocity first. So the average velocity, V average, will equal to x at time equal to 2 minus x at time equal to 1 divided by 2 time equal to minus time equal to 1. Now, what's x at time equal to 2? In that function, what was the function?
X equals
Each time you see t, put 2.
I did that.
which is going to be 2 times 2 to the power 3 plus 2 plus 1 minus every time you see t, put what t equal to 1. So that's 2 plus 1, that's 10. Over 2 minus 1. That should equal 2. That's 8, 16, no, that's 8, 16, and 19. That's 19 minus 10 divided by 2 minus 1, that's 9 meter per second. This is part A.
Okay.
Now, part B, derivative. So that's how we write the derivative. Yes, you're right, x prime, you're right, which is equal to v, which is equal to dx by dt. All of those are different ways to write derivative. Equal to 6x squared plus 1. Now, put time, sorry, t squared. Put time equal to 3.
That's good.
Yes. Good. Okay, guys, we have an answer. Yeah, plus 1. Oh, yeah, I'll teach you how. Can we find the derivative of that? That's dx by dt. That's equal to 2, as it is, times 3, that's the power, times t to the power of 3 minus 1, which is 2, plus, there is power here, that's 1. 1 times t to the power of 1 minus 1, 0, and anything to the power 0 is 1, plus 7 times t to the power 0, and we have agreed that the derivative of a constant is 0. Then the function is going to be 60 squared plus 1. And that's the derivative. Okay, do you have an answer, guys? What is the average velocity? 15? 15? Okay. And meter per second. What is the instantaneous velocity? 55? Guys, 6 times 9, that's 54, plus 1, that's, I guess, 55. Okay. Okay, guys? Good. Now we know how to find, if we know the position as a function of time, we know how to find the velocity. And when I say velocity from now on, I mean instantaneous velocity. But if the velocity changes with the time, if the velocity is not just 55, let's assume that that function was, look at the velocity here, the velocity is equal to 60 squared plus 1. If we have that function, then the velocity equals to, again, when I say velocity, I mean instantaneous velocity. So v equals to 60 plus 1. Am I right? Squares. 60 squared plus 1. Am I right? At time equal to 1 second, what is the velocity? 7. At time equal to 2 seconds, what is the velocity? 25. What does that mean? The velocity changes with the time. The velocity change, it increases, actually in that function, it increases with the time. At time equal to 1 second, v at time equal to 1 equal to 7 meter per second. V at time equals to 2 equal to 25 meter per second. The velocity change with the time. And if the velocity change with the time, we say that the object moves with an acceleration. And when we say acceleration, then we mean that the velocity of the particle, of the object, changes with the time. That's it. How can we find the acceleration of that object? Well, simply if you know v, if you know what is the velocity as a function of time, all what you have to do is to find the derivative one more time, dv by dt, and that's going to be the acceleration. This should be the acceleration of the object. Guys, can you tell me what will be the rate of the change of the velocity with respect to time? The rate of the change of the velocity with respect to time. That's the meaning of acceleration. It means that the velocity changes. The velocity is not constant. Can we calculate the acceleration? Yes. The derivative of that function is going to be 12t. 12t. Now we know what is the acceleration. How can we find the acceleration? Okay, guys? Okay. So now we know the definition of what is the derivative of 6t squared. Okay. So now we know what is acceleration, instantaneous acceleration. We can write it that way. It's dv by dt. Or we can write it that way. That's how we read it. The second derivative of x with respect to time. We do the derivative for the position twice. Once to get the velocity, and one more time to find the acceleration. So we can write it as, in a mathematical form, as dv by dt or d2x by dt squared. Same thing. It's just a representation. We represent it in that way. That should not scare you off. Okay, guys? Okay, good. How about average acceleration? If we know what is the meaning of average velocity, we should be able to find out the average acceleration as well. Same thing, same concept. It's the velocity at time equal to t2 minus velocity at time t1 divided by t2 minus t1. Just tell me what are those two times that you need to find the average velocity between them, and I will easily calculate it. The same way we calculated the average velocity a minute ago. That shouldn't be any different. Okay, so in short, what we have learned so far is the following. If we know x position as a function of time, if we know it, then we can find the velocity by finding the derivative of the position as a function of time with respect to t, and we can find the acceleration by finding the derivative of the position twice with respect to t, or the derivative of the velocity with respect to t. And those three graphs that represent position, the change in the position with respect to time, which is velocity, and the change in the velocity with respect to time, which is acceleration. Look at that point. What is the velocity at that point? It's constant. No, the velocity is not zero. The velocity is not zero. It's constant. It does not change. And if the velocity does not change, you get acceleration equal to 0. Okay, guys? Yeah, and at the maximum or at the minimum, the change in the function is 0. It does not change. At the peak or at the minimum point, it's 0.
And we find that the maximum velocity is going to be where the x-t graph is going to be small.
Yeah. When the slope is the highest, the slope of that curve here is at its highest point. Okay? Well, if we multiply, then we should divide. If we know how to multiply two numbers together, then we should be able to divide two numbers together. If we know how to do derivative, then we should have another mathematical function that's the opposite of the derivative. Okay? And we call that integration. So let's assume, guys, I'll go back to the board before we continue here. Do you remember the function? I'll keep it in here and I will erase all of that. And I will come in here and yes, and that's dv by dt. Acceleration can be an average acceleration, and its definition is delta v over delta t, change in v with respect to time. And we can have an instantaneous acceleration, that's dv by dt. Okay? Okay, away from that, let's assume that I know v. We know v, which is given by okay guys? Yeah, 60 squared plus 1. Can you find the acceleration, instantaneous acceleration? Good. If we know v, can you find the position as a function of time? Well, I did not teach you that. I taught you if you know the position, how can you get the velocity? By doing derivative, by doing dx by dt. But if you want to go backward, what to do? Do exactly the reverse to that process. To get from x to v, what did we do? To get from x to v, we subtracted 1 from the power and we multiplied by the old power. So we add 1 to the power and divide by the new power. I'll say it again. For the people who know how to do derivative and integration, you should not listen to me. If you know how to do it your way, which is exactly the same. But if this is the first time you see that, just pay attention with me. On the other board, we had x equal to 2t cubed plus t plus 7. And v, we got v by doing the following. 2 stays the same, multiply by the old power, subtract 1 from that power, right? Right, guys? Okay. Plus, same thing. We'll continue doing this. Then we got v, which is that v. Now, if we want to go backward, what to do? X equal to 60 squared. Actually, add 1 to the power. And divide 6 by the new power. Plus, add 1 to the power. Because we have a t to the power 0 in here, do not forget that. We have a t to the power 0. And divide by the new power, which is just t. Plus, just a constant. Just a constant. That constant in our case is 7. How can we know that it's 7? That's a totally different story, and we'll talk about it later. But for now, the function, if we know v, we do an opposite to the derivative, and we call that integration. Oh, later, I'll teach you how to do it. How to get that 7 later. Yes. If we know, are you ثانوية عامة? If we know the boundary condition, if we know position and time at least one point, if it's given to us, we call that boundary condition. Okay, guys? So we do the opposite to the derivative, and we call that integration. And it has a weird shape. So if you need to find x, you do this. The integration, that simple means the integration of v with respect to time. And that process, we call it integration. The process is you add 1 to the power and you divide by the new power. It's simple. You add 1 to the power and you divide by the new power, then you can get. So now, let's do this. Again, assume that I don't know this. Again, I'll go back. I'll do it one more time. We need to find the position as a function of time. Position, that's the derivative, sorry, the integration, that simple means the integration of the velocity with respect to time. So it's the integration of the velocity, which is 6t squared plus 1 dt. And that dt, we're not multiplying that by dt because this is a common mistake. Most of the people who when they start doing integration, they multiply by dt. It's not a multiplication by dt. It's just a reminder that we're doing the integration with respect to t. So if we have an here a y, this is a constant. Anything except t is a constant. Is that clear? Now, so we need to do the integration of t squared. T squared, that's t to the power 3 divided by 3. And here is the 6. Plus t to the power 1 divided by 1, and here is the 1. That's x. That's 2t cubed plus t plus a constant. And forget that constant for now. Forget it for now. Okay, guys? Good. Now we know how can we calculate get the integration of any function.
If there was a y in here, what will you do?
It's constant. Put it as it's if there was a y in here. Let's assume that x equal to t to the power 3, 2 plus y. Okay? Then the integration of x. Sorry, that's v. That's v. The integration v equal to t q plus y. That's the function. Okay? Then x will equal to the integration of v dt, which is equal to the integration of v that should equal to t power 4 times the 2 stays as it is. Okay? Plus, do you have t in here? Yes, we have t to the power of. Then it's going to be y. It's a constant. Exactly, you treat it like the 2. It's a constant. T to the power of 1 divided by 1. Okay? Excuse me? Plus constant.
But if y is a constant,
If y is a constant in that case.
it has to be y, t to the power of y plus 1.
No. Y times t to the power 1. 0 plus 1, which is? Okay? Okay. Now we know how to do the integration mathematically. What does the integration mean? Simply, integration means that if you draw a relation between v and t, that's the relation between v and t, and if you need to find the integration for this, it's exactly as if you're finding the area under that curve. Look at that curve. Weird shape curve. How can we find the area under that curve? ثانوية عامة, right?
Is the area the displacement?
Exactly. It is the displacement. It is the displacement. There is a rule. How can you get the rule? Excuse me? Oh, how can you do that?
Honestly, I can't.
Okay.
We break the curve into two
2 or 3 parts and you draw a trapezium
Mhm.
and calculate the area.
That's exactly what you see on the board. Okay? What I did is, since this is a curve, I have to make an approximation. T and V. Assume that this is the curve. I choose a period in here that's almost, this is almost a straight line. Then, can you find the area of that shape under that shape? Yeah, that's easy, almost a triangle or so. Actually, then I choose another area that this is almost a straight line. Then, exactly. Then another area that this is almost a straight line. Then if you can keep doing this and add all those areas together, then you find the area under the curve. Wait, yes. Yes. All what you have said now, it's an approximation, it's not accurate, this is really true. How can we make it accurate? By making that interval very, 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 very small. So divide those to infinite number of small triangles, rectangulars. And that's what you see on the board, almost. Because if I divide them to infinite number, you will see only lines, guys. And that's what the integration do. It's accurate because it divides those into infinite number of small areas, and you get an accurate answer for that. So that's what the integration do. Okay, guys? Okay? Okay, now in this whole course, we're going to assume that the acceleration is constant. The acceleration does not depend on the time. Acceleration is a constant value in the whole course. Saying that, and knowing how to do integration. Now, assume that A is constant. Can you find V? What's V? It's velocity. That's the integration of acceleration with respect to time. Because we know that acceleration is the derivative of the velocity. Acceleration is the derivative of the velocity. That means that the velocity should be the integration of the acceleration. The reverse of it. So if we know that velocity is the derivative, the integration of A with respect to time, what is the velocity? Do we have a t in here? This is constant. Assume that constant is 2, 3, 4. It's just a constant. Do you have a t in here? T to the power 0. Now, let's apply the integration rule. Constant stays the same. T to the power of 1 over 1. So I'm not going to write that one nor that other one. At plus constant. What is the unit of that left-hand side? Guys, what is the unit of that left-hand side? Meter per second. What is the unit of A times T? It's meter per second. What is the unit of that C? It has to be meter per second. Can we add something that has no units to meter per second? To something that has a meter per second? If you add two things, they have to have the same units. Can you add dollars to Egyptian pound? They have to have the same units. That C has to have the units of meter per second. That C is a velocity, some sort of a velocity. What kind of a velocity? At time equal to 0. At time equal to 0, what is the velocity? C. Which means that C is the velocity at time equal to 0. It's the initial velocity. So I'm going to write it instead of C, V0. V0 means V at time equal to 0. V at time equal to 0, initial velocity. Does that make sense? Should I say it again? I'll say it again, but on the acceleration. So we'll repeat the whole thing again, but when we talk about acceleration. If we know the velocity, I'm sorry guys, when we talk about position, sorry. If we know the velocity, which is this, V equal to V0, I'm going to rearrange it, plus AT. Can we find the position? Yes. By definition, it's the integration of V times dt. It's the integration of V dt. Muhammad, can you help me doing this integration? At least the first one, V0 dt. I'm going to ask you something. Do we have a t in here? Yes. Yeah. We have t to the power 0. V0 times t to the power 0. Correct? That's the same trick that we have done before. Now, can we do the derivative of that part only? It's V0 as it is times t to the power 1 divided by 1. Done. Can we do the integration for that part? Yes. It's going to be a times t, add 1 to the power, divide by the new power, half, correct? Right? Plus constant. Perfect. I'm going to rewrite that equation again. I'm going to clean it a little bit. I'm going to rewrite it on here, in here again. It says that x equal to constant plus constant plus V0t. I'm going to remove the ones because they mean nothing. Plus 1/2, that's 1/2 over 2, that's 1/2 AT squared. Once more, what is the units for that new constant? It has to be the units of that x. It has to be meters. At time equal to 0, look at that equation. At time equal to 0, this term is 0. That term is also 0. X equal to c. That means that c is the position of the object at time equal to 0. So I can rewrite that equation as x equal to x0 plus v0t plus 1/2 a t squared. Look at those three equations. 1, 2, and 3. Look at them. Equation number 3 gives us the position if we know the initial position, the initial velocity, the time, and the acceleration. The second equation gives us the velocity at any time t, knowing v0 and a. The third equation gives us the acceleration. Those three equations, we call them the kinematic equations. Do not memorize them. They will be in the formula sheet. But the proof, how did we get them? They make you understand what is the meaning of everything in those equations. Okay, guys? Do not memorize them. Do not memorize. Do you understand it now? I believe that you can do it at home. I never answer those kind of questions. I never answer what will be in the exams. Are you going to have in the exam a question that says blah, 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 blah? I have no answer for those. I'm sorry.
You know, the first one was 8 was gone.
That we have assumed from the beginning that along the whole course, we're going to have a constant acceleration. That's an assumption. So that if that's different, then the whole equations will be different. It is a given equation. A equal constant. It is an equation. There is another kinematic equation that I believe that you can find it. That it says, of course I memorize it because I have been teaching that course for so long, but you do not memorize it, guys. It says V squared equal to V0 squared plus 2A times delta x. X minus x0, yeah. This is another equation. I believe that you can find that equation. You can prove it yourself. Okay, guys? If you don't know how, it's in the presentation. But try to do it yourself first. It's very easy. It's very simple. Yeah. Okay, guys? Sure.
This equation, this one, yeah. So does that mean that if you have, for example, 2t squared in the equation, does that mean that if you do 2 divided by, and then the equation is 1?
Yeah. Yes. Yes.
Now, if we differentiate x, we will find b. And if we differentiate b, we will find a.
Yes.
What if we differentiate a?
If it's constant,
If it's not constant?
you get something, you get the change in the acceleration, the rate of the change in the acceleration. You can call it whatever you want, but it's not really integrate x. You get what if you integrate x? That's interesting. If you integrate x, then you get another physical quantity that does not have anything to do with kinematics. That we don't really need it. It's meaningless. But you will get something, but it's meaningless. What you need to know in this course is, if I give you the motion of an object, you need to find the position, the velocity, and the acceleration of that object at any time. And those equations give you that. Okay?
So if we integrated x, we'll get equation number 2.
If you integrate x,
Oh, okay. Okay.
you get something before x. Okay, guys? Do you have time? No? Okay, thank you. I'll see you next week. Enjoy your weekend. There is an assignment due next Thursday, and it's on Blackboard.